This is probably the last video covering the fundamentals of sets. In the next video, we will start with relations. Okay, so in this video, we will see once again the arbitrary two sets using Venn diagram and arbitrary three sets using Venn diagram, and how to just write some set formula just by looking at the Venn diagram. Okay, for example, you know what is A minus B? A minus B is this region. Means in context of set A and set B, those elements of A that are exclusive to A, means those elements of A that are just that belongs to A but does not belongs to B. So as you can see that this is a set A, and A minus. A minus means that from set A you are removing some elements. So what elements are you removing? The elements that are present in B. That's how we look at set difference. um, so this is the region for set difference, right? This is the region for set difference, A minus B. So how can you get this A minus B? One of the way we have seen that, which is this is nothing but A intersection. So if I am doing A intersection, then what should be here? So this is whole your A, then intersection, whatever you are going to write here, that has to include all of this, and that doesn't should not have this area. So, and this is the thing but B complement, because B complement don't have this area, and it have all of these, no doubt, but it also have this. So the intersection region is nothing, is only your required shaded region. This is one thing. Or you can say A minus B is A. From A you want to remove some elements, right? A minus something. So from A you want to remove the elements, some elements of A which is in intersection with B. So A minus A intersection B is also can also be your one formula. So A minus B can also be A minus A intersection B. So from A you are removing those elements that are also in B or that are in common with B. Okay, intersection B. A intersection B is from A you want to remove those regions that are exclusive to A. You can say that this is A minus. From A you want to remove these regions. So these regions are A minus B. So it is A minus A minus B. A intersection B is A minus A minus B. Okay. A XOR B. You include all the elements from A and B which are not common elements. So you are including these regions and these regions. So this is A minus B union B minus A. Maybe we have visited these formulas before. I am just using this video to show how you can just look at Venn diagram and try to come up with a formula. We have not seen a lot about three arbitrary sets. I am using this video. The main purpose was to introduce the union between the three sets. Like we have seen A union B, right? We know what is A union B, but there is something about A union B union C that I want to cover in this video. That what is A union B union C? Because if you remember, in the union of two sets, we saw that the okay, from the arbitrary Venn diagram you come up with a inclusion exclusion principle, like number of elements in A union B is equal to number of element in A plus number of element in B minus number of element in A intersection B. This formula is called inclusion exclusion principle, because in just straight away writing all the elements of A and B, you will write the common region twice. That's why you will have to subtract the number of elements in A intersection B. And if the sets are disjoint, this number is nothing but 0. So this is a general formula that will encapsulate every situation. In a similar manner, now we will look at the that how what this formula will turn into if we don't have only two sets. Number of elements in A union B union C. That's what we will see in this video. Okay, I will erase this. Let's say if I write that the number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C, then actually we are counting some elements twice, some elements as thrice. Let's see how. Look at this region. Look at this region. This region. When you straight away write the elements of A, you are including this region once, this area once. But when you are writing the elements of B, then this region is now counted twice. Okay, so you have to from this sum you have to remove minus number of elements in A intersection B, because these elements are counted twice. Similarly, uh, this region, this region, when you are listing all the elements of B and C, these elements are being counted twice, so you have to remove them one time, so it becomes minus number of elements in B intersection C. Similarly, if you look at this region, when you are writing the elements of A and then element of C, then these regions are being counted twice, so you have to remove them once. So number of elements in A intersection C, and then look at this region. If you look at this region is in the intersection of A also, in the intersection of B also, in the intersection of C also, and this region is being added every time. Means when you are adding A, when you are listing all the elements of A, then this region is added. When you are listing elements of B, then this region is added, and when you are listing elements of C, then this region is being added. So they are added three times. But when you are subtracting the intersection of A intersection B, then A intersection B not only includes only up to this region. A intersection B includes all of this. So because these are counted thrice, no doubt, but you are also while subtracting elements common in A and B, common in B and C, common in A and C, you have actually not included this region. So you have to add it. You have to add it plus number of elements in A intersection B intersection C, because no doubt it was added thrice, but because we have subtracted A intersection B the one time, the elements of A intersection, number of elements in A intersection B, you have subtracted